Hey guys, welcome to a Friday night restoration. Yes, you heard me right. It is the return of the Friday night restoration. For those of you who haven't been with the channel for a while, it's something I used to do back in my single days in the apartment when I was doing work for customers as a way to kind of blow off some steam, relax a little. When I first started doing it, I was working on some tough dog projects, frustrating, that went on for weeks, and I wanted something quick and easy and satisfying. Start to finish, one installment, and at the end we turn it on and it works, and we get a little bit of satisfaction out of it. Over the years I gradually stopped doing them. It's probably been 5 years since I did one. So without further ado, let's get to it. So this will be, unlike a lot of my videos, especially one lately on the Fluke 90, no nonsense. We're going to quickly take a look at it. We're going to get in there. We're going to start working on it. And no research, no experimentation. We're just going to get it done. So what is the subject of tonight's restoration project? A Fluke 9T1, a classic 8-inch Motorola TV from 1949. Now, a TV may seem like a pretty daunting project for just a few hours in one evening. However, I have more experience with this chassis than any other, and I've got plenty of spare parts. Plus, this one is something special. Motorola made 3 versions of this set. There's a portable with a Tolex covering, there's a wooden mahogany veneer cabinet version, and then there's this, which is the bakelite version, which arguably is the coolest looking with this kind of bulging screen here. So what makes this one interesting is the remarkable condition. Condition is, and rarity is generally everything in the TV collecting field. So while this one isn't especially rare, this one is in the best condition I've ever seen. So let's take a quick tour around it. So it's bakelite, which is fragile and prone to scratching and dents and dings and cracking. This one is in really good shape, except for a minor scratch up front, which maybe we can fill in with a little bit of brown wax or some such. No cracks, no major issues whatsoever, except for this. It looks like somebody sanded it with some really fine grit sandpaper, like maybe 800 grit or something. All I can think is that they were trying to sand out something. A defect, there is a scratch still present here. I don't know. We will do our best with some Novus polish and whatever else I've got on hand to see if we can make that look a little bit better. This bakelite cabinet is like an M&M. It's got a shiny hard shell. It's very thin, and once you get too deep through it, it's not going to look the same. Anyways, other than that, defect free. The knobs are all present, but the brass inserts did come out. I believe at least 2, if not all 3, are present inside the cabinet, or so the owner told me. If not, I'm probably dig one up. Now, condition. It's remarkable. So we've seen the cabinet. Now the back. It's lucky enough to have the back to a TV. This one is virtually pristine. I don't know if it's ever been opened since the set was made. The screws are still both present, and there's no gouging like there would usually be from somebody getting a tool on there and unscrewing it. It's a hinged piece of masonite with a little cup here for the CRT socket. Original line cord, still in perfectly usable condition. The label is pristine, copper-plated chassis, no corrosion. Even the knobs are nice and shiny. I can't wait to see what it looks like inside. As is so often the case with electronics from this era, 1/4" nuts holding everything together. We're going to very carefully take these out. Oh, that's a nice touch. There's actually a brass eyelet. Often they just drill a hole through the masonite and drive a screw into it, and that's why they get so torn up. But that is, for a budget set, that's a nifty feature. So that's just it, 2 screws. Alright, let's see what we've got. Oh, there's an AC safety interlock there. Now you got to be careful when you flip this lid up that you don't just let it flop down. I'll go, there's some tension on it, because you can, if that smacks down on the cabinet top, you can gouge it. I'm going to go hands-free so we can explore better. There's a bag in here, and I see at least 2 of the knob brights with a little Motorola squiggle on them in there. Alright, we can glue those back on. Alright, so copper plated chassis. It is a TS18, model number 340301. Still has the original labels all over, original tube chart. Yes, that is asbestos. There is a ballast in these. These are series strung sets. They needed this to burn off some of the extra juice, and they get really toasty. There's also an internal antenna that's flopped down a little bit. And it's been disconnected. Originally this would have connected to these lugs. Somebody would probably use an external antenna, so they disconnected that. Alright, so what have we got inside? Well, right away I can see at least 1 tube, 2 tubes are labeled Motorola. The ballast is labeled Motorola. I see a fine layer of dust. Otherwise this looks pristine. Let's pop some tubes out and see. Is it possible that this could be... I'll have to pull the chassis out to know for sure, but I'll at least pick another tube out. Motorola 12SN7. Huh. That is a very, very encouraging sign. 12SN7, 6SN7s, as they get used, get spots above the 2 triode elements from material getting boiled off and redepositing, I suppose. There is barely an indication of any discoloration whatsoever. And look how clean those pins are. What does this likely mean? What it likely means is these are the original Motorola tubes, and this set has barely seen any use at all. Let's pop this little guy out. As the rain falls. Wow, this is exciting. This could be 100%. This set may have never been in service. I will contact the owner about the ballast. You can just leave the original one in there, and it will get hot, or we can. I've talked endlessly about making reproductions that don't generate very much heat. I could put one of those in there, and you can hang on to the original D-Lakes. Speaker connections are hard to get out. Okay, now we need to get the feet off. I have this on a cloth so it doesn't get scuffed up. Here's a look at the underside. Let's see here. But the feet are so mushed down that I can't really get this on without. I'm going to have to kind of destroy the feet. The rubber is mushed down. These might be 5/16. So it's always a 1/4 inch except when it's not, and then it's 5/16. Or it's just so grunged up from its feet that I can't even get my tool on there. Oh yeah, they are 1/4 inch. Alright, so everything in this set is a 1/4 inch. That should be enough. I'm putting my hand underneath the high voltage box. It's a handy place to grab on. This chassis does not weigh very much at all. Less than 10 pounds, I'd guesstimate. Okay, so let's rotate this around a little. And just slide it out. Careful of all the cables. And that's all there is to it. Here's the top side. It's got some surface dust, zero corrosion, little cadmium sulfide on some of the plated metal. Motorola, blah blah blah, Motorola. Motorola. Every single tube is Motorola. Cool. Okay, here's the exciting underside. And it is 100% original. Sweet. Which I have encountered once or twice before. In fact, I did another, I think it was a Friday night restoration on a similar set where I restuffed some of the caps. Now, I don't have the time to restuff all of these caps tonight. But I will certainly keep them all, and I will contact the owner, and if he would like me to, I will restuff them. For now, we will tack in new caps. And even the tape holding these two caps together. So there's a few unique oddities to these types of sets. A big one is down here. We have 6 gigantic paper caps. These are all caps rated for 6,000 volts. 4 of them couple the deflection waveforms to the plates on the CRT. One of them is to filter the high voltage supply. You need special caps to replace these with. I have them on hand, not a problem, but that's not something you can just pick up anywhere. The rest of it is pretty conventional. There's some basic paper caps in here. One lone electrolytic, I think that's on the ratio detector for the sound. There's a lot of ceramic caps in this, which is one reason why it's fairly reliable, easy to work on. These are tubular ceramic, incredibly stable and reliable. There's some really disc ceramic in here also, tend to be very reliable. Super simple tuner, just a rotary switch. And these coils, do not bump into them, do not touch them. They spread apart and squeeze together these coils of wire to form the inductors to tune in the various stations. Don't mess with them. That would be this guy. So to save time, like I said, to have fun, I'm not going to check anything. We're just going to start going for it, and we'll address problems as they arise. I've got the lights dim now because if this is a really strong CRT, we should be able to see a splotch on the face of it while we're testing it, even though this only uses several hundred volts versus the several thousand it would normally run on. First, let's just see if we can get a filament glow. Get this up to 6.3 volts on the filament. Now there's a shield in place, so it's hard to see. Okay, I can see a little reflection of some of the glass elements inside. I don't know if you can, but it is glowing. There is some illumination going on in there. There, you can probably see that. Alright, cool. Alright, let's go through. Check for shorts. No heater cathode shorts. No G1 shorts. Cutoff control. A little flaky, but it is responding. That corresponds to the grid control. That means that you can vary the intensity of the image. And now, oh yeah, sorry, emissions. It's a little dubious testing emissions on these because you kind of really just need to get on a working set to know for sure if it produces a good image. Hey, we've got a splotch. Excellent. For sure, this CRT will produce an image. Considering how low hour this set appears to be, I suspect it's going to produce a very bright, clear image. Fantastic start. Now we're going to put this away safely in another room. We're going to get out a green CRT, hook up a test speaker, and we are going to try to slowly bring this back to life. So here's what we're going to do. First up, green phosphor CRT. It's a 7JP1/VP1. That just means there are two different tube designators. Characteristics are the same. It's 7-inch, it's completely pin compatible with the 8-inch, be no problem. These aren't exactly common either, but more common in the 8-inch black and white variety. This came out of a actually kind of an inexpensive oscilloscope from shortly after World War II, and I do believe that these were initially made for oscilloscopes, and then they got kind of repurposed for early televisions by putting a different type of phosphor on the front. I could be wrong. All right, now the ballast. I don't know if this is good, and I don't want to risk frying it if there's a short somewhere. There are thin wires in here, like a toaster element inside there. There's a mica sheet with like nichrome resistance wire. We're going to put that aside, and we're going to use one of these bad boys. Don't ask me where I got it. Well, I can tell you where I got it, but they don't have any anymore. I got it off of eBay from a tube vendor who had a supply. I picked up a few years ago. These come up for sale very rarely. It is the amperite version. So now you can see mica sheets, resistance wire. What's the difference? This has hydrogen gas inside, and that is a type of iron alloy wire. What does that do for you? Well, see, it's called automatic regulator. Yeah, this actually regulates the current. The hydrogen, I believe, gets in between the iron atoms and somehow provides current regulation. It'll resist changes in current, is what I'm trying to say. It's sort of a current regulator. Kind of provides a soft start, sort of like a thermistor. And we're going to pop that guy in. Well, it still gets friggin' hot. You can't avoid that. Let's look at these tubes a little more. Now this one does show a little bit of a splotch on top. That is a 25L6 that is used for the audio output. Another 25L6 over here for the high voltage generator. There's an RF coil in here, or an RF high voltage supply they call it. It's a feedback oscillator with a 25L6 audio output tube. There's no flyback, there's no yoke on this thing. It's sort of a self-resonant oscillator, step-up transformer thingy. Alright, and finally a speaker. We'll just use this touch speaker that I use for everything, and we need some alligator clips, and we will clip that up. And then we are going to start slowly powering this up with a variac / isolation transformer / ammeter / voltmeter, so we can check, monitor everything. Ideally, you would check the B+ voltage. I don't want to mess around with that. I don't want to have to rig up stuff underneath the chassis. I want to just keep it like this. We're going to rely on this device. Flip down the kickstand on it so we can see it better. And we're going to dial that way down before I even plug it in. So the power cord is part of the cabinet, so I need to go grab a cheater cord that I can plug into the back. In other words, if you're wondering why they call it a cheater cord, it's because you're cheating the AC safety interlock. The idea is when you take the cover off the back of a set, you're not supposed to be able to plug it in. That's to prevent consumers from shocking themselves while they're poking around and changing out tubes and stuff like that. We're cheating that. We're cheating the safety feature so we can plug it in because we know what we're doing. Here is the cheater cord, non-polarized. Plug that right back into the back of the chassis. One final thing I dug up, hopefully we'll be using at some point, is this. I've recommended the Fluke 27 multimeter a number of times. This guy. If you get the full kit, it comes with this, which is a 6,000 volt probe, which is perfect for these sets because they run at around 4.5 or 5,000 volts. Okay, let's get to it. Dim the lights again so we can see anything bad happens, even better. I mean, like if there's any flashes or filament glow to see or whatnot, although we're going to start with a really low voltage, so there shouldn't be any filament glowing. Okay, I'm going to unplug this set first so I can see what this thing is putting out in its lowest setting. So AC output volts. Wasn't sure how low this goes. It probably does go all the way down to 0. Some variacs don't. Looks like you can go from 0 to 150. Okay, so we'll go to 0. I'm going to plug, well, let's make sure this set's... There we go. Okay. The leftmost control, that's power volume. So the set is off. I'm going to plug it in. Back the camera up a little. Okay, I'm going to turn the set on and I'm going to switch this to current mode on the most sensitive range, which is 0 to 1.5 amps. When fully operational, this set draws a little over an amp, maybe 1 1/4 amps, something like that. And it is on. And there is 0 current draw. Why? Because we have 0 output voltage. So let's turn it up a little. Let's see, it's topmost scale. Let's go to 10 volts. Now the fact that I can get to 10 volts is a good sign, because that means we don't have a dead short. And current wise, yes, we are drawing 1/8 of an amp. Alrighty, I am going to increase this. So let's leave it. So I'm looking at current. Let's get to where we're drawing. It's hard to read the scale, like around 0.35 amps. And it's dropping off a little bit. That's an excellent sign. So as these capacitors, they need to reform. They've been sitting around for decades. They need to build up their oxide layer and do their thing. The leakage current needs to drop off. That takes some time. And as they form up, the current draw should go down. Also, as the tube filaments heat up, the resistance will go up and the current draw will go down. So the idea is to keep an eye on this, and again, ideally you would check the actual like B+ voltage underneath the chassis and that, but I don't want to get into it. Also, this is a transformerless set. Not a hot chassis. The chassis floats, but there is a shock potential underneath the chassis. The AC line voltage, it's not isolated, it's just running all down through. The tube filaments are wired up in series. So you should use an isolation transformer. Certainly before you hook up any test equipment or go poking around underneath the chassis. But the chassis itself is, well, at least it should not be connected to either side of the AC line. Okay, so our current draw has dropped off to about 0.3 amps. Let's go up again to where it's at about 0.375, 0.4. Okay, we're at 0.4 amps. And let's see what our output voltage is. We're at about 33 volts. And I'm going to let it sit here for a couple minutes, and I'm going to keep doing this and keep doing this, and I don't expect really to see anything happen until we get to around 80 or 90 volts. Then maybe we'll start hearing a crackling out of the speaker. Current dropped from 3/4 down to 0.7. Let's get it back up to 3/4. Alright, this back filter cap is getting a little warm. Could be picking up some of the radiated heat from this, but I don't think so. I think that's some internal heating. This one is cold. This one can't tell because of the cardboard sleeve, and I don't really want to touch it anyways. Tubes are all glowing pretty well, except for, well, no, it is, I guess, just difference in manufacturing. This one 12SN7 is kind of dim looking. Everything else looks right. Voltage, we are at 80. Let's kick it up a little bit. Let's go to 0.8 amps. volts. This is where I was theorizing we might start to see some signs of something. I'm going to make sure I get the intensity up all the way on the CRT as well. Memory serves. No, the control's not where I thought it was. Intensity, oh here, it's this guy. Oh, we have something. Rotate that sucker around. Let's see, this would be focus. It can kind of focus. That is horizontal centering. That is vertical centering. It's probably a leaky cap because I can't really get it to go down from, I can get it to go up from center, but not really down from center. That would be width, I think. I'm getting a little concerned about how warm this cap is getting, and the one next to it's starting to get a little warm too. So I'm only going to run this intermittently, and right now I'm going to go for it. Go for all the way up to 110. And I'm not going to run it very long, and in the near future I am going to pop in some replacements down below. So we're at about an amp now, and not much has changed. Except now we've got reception. Let's turn this off. Grab an antenna and see if we can hear some reception. Okay, I've got a bit of an antenna hooked up now. Just a random 3-foot long hunk of wire clipped to one of the antenna leads. Should be enough to pick something up, I hope. Notice the deflection isn't any better though. You know, it's still only about an inch vertical. Vertical is always an issue on vintage TVs, it seems. We're just going to go right up to 110 now. And we're drawing about an amp. And there we go. It must be channel 6. Well, it looks like there's some indication of video too. Contrast all the way up. Swing around. Of course, the horizontal vertical holder right next to the regulator tube or ballast tube, so you can roast yourself. Hey, we've kind of got something now. I've been forming up these caps for a couple hours now. I think they're about as good as it's going to get. They do get pretty warm, especially the one in the back, so I don't want to run this set too long, but I have worked my way up to 117 volts. Well, I said this was going to be a no-nonsense project, so I just went ahead and rebuilt the power supply. I'm not going to screw around with caps that are hot after several hours of trying to reform them. So, selenium's out. I left them intact with the wiring, in case anybody wants to get them reinstalled for cosmetic purposes. Now this is all temporarily tacked in just to get the set running. 2 new rectifiers, one N5408 3 amp diodes ready for 1000 volts. There's our new cap on the front end of the voltage doubler, and here's the other voltage doubler cap. I got a couple flavors of a schematic here. It's probably easier to see on this one. So that is what I call the first voltage doubler cap. There are 2 diodes, and there's the second cap. Then there's a resistor, and then another filter cap forming a pi filter. That resistor is actually inside of the ballast tube. And that final cap there before the main B plus rail is that guy. So yeah, you're ever poking around on these and you want to measure B plus, this bare wire that goes to the brightness control, that's your B plus right there. Uninsulated, that's how it came out of the factory. And there's a grounding point on your, remember the chassis is not ground, it's just wires floating around. So right across this pot is your B plus and your B minus, they call it on some schematics. Got two flavors of it here. This is a Sam's, that I think is easier to read, but it's got some mistakes, like 3 and 4, 3 and 4 here are backwards. This one is correct. See, they've got pin 3 going. They call it B++ on this, and then B+ is the secondary rail. There's a higher B+, and then there's a lower B+. They call it a stacked B+ design. Anyways, pin 3 is your main supply that powers the set, not pin 4 on the Sam's. It's the only mistake I know on the Sam's. So we've got 4 new electrolytics in there. That guy, that guy, that guy, and then the one over on the video amp, that guy. The only 2 that are not done yet. The 20 microfarad bypassing the audio output. We've got pretty good sound, so I'm not too concerned about that one. And this guy, just because it's a little awkward to get at. I want to try powering it up. I mean, that's the first step of any project, really, is get a stable power supply, because until you've got that, nothing else is possibly going to work right. I'm going to flip this down, hook it back up, and I'm also going to get an over-the-air converter box so we can actually get a strong signal going into this. Okay, here we go. Everything's lighting up. Current draw. Looks about right. 0.8 amps. Here comes our raster. It's good. Didn't screw anything up too bad. Let's see. I still have this on channel 6. Ooh. That's super encouraging. Really good sound. Let's see about hold. Where's that? Yeah. Grocery store mystery steaks. Nice. Wow, this set works amazingly well with virtually no work. Just a few new caps on the power supply. Now, obviously it's the wrong phosphor type, but the persistence is very similar. I was just double checking the power going into the set. 117 volts and 0.9 amps, a little less than I thought. It was a little over an amp. Anyways, let's play around with the controls. There's a whole bunch on the back. This one is focus. Ooh, that's the best focus we can get. That's not good. I'm all at one extreme. There's a string of high voltage resistors. I bet they're off. Also, this is a horizontal centering. I gotta max it out to get it centered. I don't like controls to be at their extreme. Likewise, vertical centering is all the way down. There's for horizontal size. So what does that mean? Here's the corner of the schematic that shows the CRT and high voltage and deflection stuff. It's a little hard to follow on any flavor of this schematic, so I'm just going to go with the one that Motorola originally put out. Here's our high voltage generator. That's what's inside that metal box. There is a high voltage filter cap here. That could be leaky, could be dragging down our high voltage. There's a whole bunch of resistors here to divide voltages down, like to provide this focus voltage. And it provides DC bias to the deflection plates, and here's our centering controls. Some or all of these resistors could be a bit off. They're carbon comp, they drift with age. High voltage can do weird things to resistors over time. And then there are 4 caps over here that couple, this is a horizontal and a vertical, it couples the sawtooth waves from these circuits to the deflection plates. Those could be leaky. These resistors need to be pretty equal in value, otherwise you're going to get an off-center vertical image. That's the vertical output tube. So, first up, I will quickly blow through and check these resistors, replace any that are way off or give me a weird reading. And by that, I mean I've seen them measure open, even when the set works, because when there's high voltage, it can kind of burn its way through, but the ohm meter shows it as being open. It can happen. And I will tack in replacements for the high voltage caps, because I can just tell the way the image is offset that those caps got to be leaky. It's probably also dragging down our high voltage a bit, which is why we can't get a decent focus. I went ahead and replaced all 5 high voltage caps, and that took care of all of my screen issues. I can center it, no problem, horizontally and vertically. We've got good linearity, but the focus, that's the best we can get, which is not good enough. Now, they don't give you any voltages or any service info I've ever seen for these high voltage points. They probably assumed that service techs back then wouldn't have a high voltage probe, so they didn't bother. I don't know, but I can look up specs on the CRT. And typical operating voltage is 6,000 volts for the second anode, which means the focus should be around 2,500 volts. Now, I can take my probe here and go to the highest potential point, and we've got about 5.3 kilovolts. That's typical of these sets. I've never seen one that actually put out a full 6 kilovolt. Plus, they originally came with 6,000 volt caps, so you wouldn't want it that high anyways, but somewhere around 5,500 is where they're typically at for the highest potential. Now, what's on the focus? Should be around 2.5. And we've got less than 1.3. Now, I've checked these resistors, all these high valued resistors in here, and they're all within spec. So something's not right. And I was also just checking, so this is a wiper for the focus control. On one leg of it, we've got 1.7. On the other leg, 1.2. Alright, so we've got some range there, but it's low. Now, how does this whole voltage divider work exactly? So we start out here, 100K resistor, we go through a bunch of resistors, focus control, and then a couple more resistors. And that goes to the plate of this tube, and then eventually electrons get through cathode and return to the return path. So this tube is actually part of the voltage divider. So if it's not in its proper operating range, that could affect things. We do have some voltages here, so we can check those. So let's see on pin 2, what do we have? Not even with the high voltage probe, I can still check other voltages. I just have to remember to multiply the value I read by 10. I'm trying to see where the key is. I think that's the key. So this is pin 2. And we've got 300 volts. And what do they say? It should be 320. It's in the ballpark. And pin 5 should be around 240. 1, 2, 3, 4. Alright, hard to get at. This is pin 5. 234. Okay, so that checks out. So what the heck? I went ahead and quickly recapped a bunch of the rest of the set. Got a nice little pile of old waxy caps down there. And the image has gotten definitely better. However, the focus issue has not budged at all. So I did some more poking around with measuring the voltages across these resistors, and for example, the 6.8 megs have over 1,000 volts dropping across them. And again, it's a 1 watt resistor. Max spec on that is to have 500 volts across it, not 1,000. Resistors get kind of warm too. Alright, as rechecked, this measures 6.2 meg, that measures 6.7 meg. So they're both a little low. They're supposed to be 6.8. But with 10% tolerance, they're within that. Well, things just keep getting stranger. I swapped out the 6SL7 for a used one, and I was able to get good focus, but the picture was all washed out and, well, looking like this. Played around with the controls, but I could get good focus, just not a good image anymore. So I decided, well, let's put the other 6SL7, the original one, back in. Now it has the same issues. I can focus. You can see we now have sharp defined scan lines, but the picture's terrible. So I'm thinking the problem all along was something else. Like maybe a tube was not seated right. I've seen advice given before. The first thing you should do is clean all your tube sockets and make sure all the tubes are seated properly. Of course, it isn't making any difference. So we had much better reception before. This was the contrast cranked all the way. To back it off a little. The contrast controls gain. So what the heck is going on? Now there are still some paper caps in there, and they very well have continued to degrade. There are still 2 electrolytics in there, which should get replaced. So rather than just chase the stuff, I will finish recapping and then resume troubleshooting, and I will grab a tube tester and test all these tubes. There's no point in me chasing problems that have a simple remedy. Some of the 6AU6s were a little weak, so they're going to get replaced. Now I'm checking the 12SN7s, and I found one that's really weak. So that's got to go too. And that's the one that has the very visible silver dots on top, which is a pretty good indication that it's seen a lot of use. One of the other 12SN7s was equally bad, and now I'm testing the original 6SL7, and unfortunately it's nearly dead too, so that has to go, and that takes care of all the tubes. In the end I had to replace a little more than half of them. I'm just about done doing the quick and dirty recapping. I wanted to show you a couple things. One, here's a 10 microfarad cap ratio detector, and it has lost its guts. Yet we still had decent sound. And with all those weak tubes in there, I think it's pretty remarkable the set works as well as it does, at least for a while. After a few minutes, you know, we basically lose the picture and focus and stuff. Hopefully this will take care of that. There's one last cap in here. That goes between B- and the chassis. Just like with that Fluke radio I did recently, that is there to complete the circuit path for RF ground, because there are some RF circuits that do tie in to the chassis, but the chassis does not provide a DC path for the B+. So it's kind of interesting. And it's ground, but it sort of isn't. It's ground with regards to high frequencies. It is not ground with respect to DC. You definitely need to have a cap in there or the set will not work properly. And here's something else I don't think I've ever seen before. A date. Usually it's on the back of the chassis. It was run underneath the CRT, so I didn't see it until just now. December 14th, 1949. Let's do another power-up test. I'm going to be doing a number of these over the next hour or two, and let it run for like 10 minutes, see if any problems arise. I'll turn it off for 10 minutes, turn it back on for 10 minutes. So excellent. Picture came in and locked. I didn't have to touch anything. Good picture and sound. Cool. So while that's doing that, I'm going to turn my attention to the cabinet and see if I can buff out that rough spot. So here's that spot. I cannot imagine what possessed somebody to do that, unless they were trying to fix up something that was even worse. We are going to take some number 2 Novus fine scratch remover and see what we can do. And then we will lightly go over the entire cabinet with this polish. Maybe a little protective wax after that. Work it around a while, let it dry to a haze, and buff it out. I've unfortunately got my doubts that we're going to be able to make this completely disappear. There might be a slight texture or a color difference. Some pretty aggressive sanding. Yeah, it's going to take a few passes. It looks better, but the surrounding area is being affected too as I polish it. So, crap. Unfortunately, while I was doing that, we lost our picture. Boy, that is frustrating. That is like the hardest thing to track down on a vintage set. There is one thing we haven't talked about. The video detector is actually a very early semiconductor diode. It's inside this little metal box back here in the IF. It's a 1N34. It's possible that's got issues, but I really would rather not dig into that if I don't have to. So I've tried tapping and wiggling everything, and nothing seems to help. Unfortunately, the intermittent problem persists. I just turn the set back on, it's playing fine. At some point I expect it's going to poop out. So while it's running well, I am going to check a few key voltages. In particular, B+, not to be confused with B++, which we're also going to check. Yeah, there are 2 B+ rails in this set. Okay, yeah, so the main B++ is low. I'm measuring 218. They don't tell you exactly what it should be on the schematic, which is annoying. But if you trace out, you see voltages on the schematic. Like here's a circuit off a B++ 100 ohm resistor, basically goes to the plate. It should be 235. So if we only got 218 at B++, we're certainly not going to get 235 there. We can't create voltage. So that's actually about 25 volts low at that point. So I popped out the amperite ballast, and I popped in one of my homebrew ones using diodes and a thermistor and some power resistors. And let's see, maybe there's something up with that ballast, and it's reducing the current flow. Otherwise, like I said, something has to be drawing too much current, and I don't know what. Ooh. Wow. We blew a cap. Well, that was fun. Luckily no harm was done. I replaced the cap, everything is fine. So what happened? It had nothing to do with the cap, and replacing it does not fix the fade problem. It still exists. The reason it popped was very simple. Is the ballast I built is incompatible with this set. Why? Because I made use of one of the unused pins in the ballast as a tie point. So did they. They tied these two power resistors to pin 5. Pin 5 on my ballast is tied to pin 6, which just happens to be the AC line coming in. So I shorted this to the junction of these two power resistors, which goes to the positive side of that cap. So essentially I put the entire AC line voltage across that capacitor. Not surprisingly, it popped. And as I say, luckily it didn't do any damage. So why did I do that? Because there are two versions of the ballast tube. One ends in 303, that's the older one, and then the newer one ends in 459. 459 doesn't use that pin, 303 does. And assuming that pin 5 isn't tied to anything, this can be popped into either set. I've used this plenty of times before, but I guess not with the TS18A chassis. So I, in other words, caused my own problem. Well, while I was replacing that cap, I did replace the one paper cap that was left buried down in there, and that didn't fix the problem. So we are still stuck. Next up, I'm going to try replacing these two resistors, even though I don't think that's going to accomplish much of anything, but they are toasty looking, as somebody commented online when I posted a photo, and they are being stressed. Alright, we don't have time to screw around, so I pulled out a scope. I've got it on the output of the detector, and we're looking right now. I got set up to do individual scan lines. The scope has some special TV modes. So each one of these downward blips, that is a horizontal sync pulse. So this is one scan line, that's another scan line. And notice they change. That is the amplitude modulated video portion. And that little squiggle there, that is the color burst. Not that this set is color. Alright, so I have monitored this set. After 10-15 minutes or so, the screen will wash out. All the voltages are still pretty much dead on with B+, B++, and the voltages throughout the RF and IF and video amp. And I've checked the resistors, and yeah, there's some that are off 20-30%, but I don't think that would just suddenly make the gain go bad. I then took a can of compressed air, turned it upside down, and sprayed stuff. What does that do? That puts out a very cold blast to cool components down. It's a way to find a hot spot. Didn't do anything. So what I'm doing is I'm monitoring the output of the detector, and we're going to see when the screen gets washed out, does it change? Because what happens is we still get full raster. And if we crank the contrast up, there's still kind of an image, but we've lost a ton of gain somewhere. Now I'm suspicious of the detector because it's not a tube. It is a 1N34 diode. This was really, really early days in semiconductors. When this chassis design was introduced in late '47, germanium diodes had just been invented, I think a year or two earlier. So that makes me suspicious. I mean, solid state's more reliable, I suppose, but not when it's one of the first diodes ever made. So we'll see what happens. I've had to dig into that box once or twice before. It's a little cramped, but it can be done. If I have to, I will replace that diode. They don't make them anymore, but I've got a little stash of germanium diodes. I think I've got one that will work. So we're looking at about 8 volts or so, peak to peak, 6 volts peak to peak. Alright, this could take a while sometimes, so I'll stop recording and I'll resume when and if the screen fades out. Alright, there we go. And the image has faded out, and what do you know? There is no more signal. after the video detector. Now, if you're wondering about before the video detector, it's a little harder to see because it's the IF frequency. But let's see. Poke around, maybe we can find it. Let's see. Okay, that's the input to the video detector. And if we do a little time frequency, it's around 24 megahertz, which is about the IF frequency. Okay, there is the input to the detector. It's a nice 6 volt, 5 volt peak to peak sine wave centered at about the... There is the input to the detector. It's a nice clean sine wave, about 5 volts peak to peak, centered on the IF frequency. So we do have something going in. And if I turn off channel, it disappears. So that is the IF frequency. We are receiving something, and those crazy spikes, that's the AM modulation. So I'm convinced now it is the detector. So what can we do about it? Well, let's try the cold freeze spray on it. I took the cover off of it to try this out. It is that assembly right there. So let's give that a little blast. I want to be subtle. There are tubes nearby. This gets really, really cold. I don't want to shatter a tube. But let's just give it a little puff. And see. Oh, how about that? We have got a flaky diode, or one of the other components. There are a couple resistors in there, possibly. One of the coils, very unlikely. And you know, so my money's on the diode, that's for sure. So let's take a closer look at that assembly, and it's pretty tight, but let's see if we can replace that diode. I'll double check the resistors. I disconnected everything and pulled some tubes so we could really get in there and see what's going on. Normally it would be under this cover, buried down in here. There is our germanium diode, surrounded by coils and ceramic caps, a couple resistors on the other side. This one's adjustable. This is all kind of like factory preset, and I do not want to have to be monkeying around with it too much. I don't want to move things around. But boy, that's tough to get at. I'm not even sure where the leads for it come out. I think it goes to these two lugs on this side, but boy, I'm not sure. Okay, it turned out to not be too bad, actually. That's why I clipped it off on the top. I was able to push it underneath this coil here and swing it down to expose the other lead, which goes to the second from the bottom lug on this side. We're going to carefully... Alright, we got it out. So here we go. Sylvania, I believe Sylvania was the first one to market these. 1N34 Sylvania, black bar on one end, it says Cath on the other side. It's in this protective tubing, I presume, because there's a metal cap on either end which is connected to the cathode and the anode, and they want to protect those from bumping into something. So let's do our diode test and see what we get. There we go. Well, one thing I don't like about the Fluke 27 is that the display is rather reflective. Make it at a good angle to see it well. Anyways, well, that's not a good sign, is it? We got nothing. I go from the cathode to the anode. Jeez, let's try the other way. Huh, we get absolutely nothing either way. Well, that's not much of a diode, that's more like an open circuit. Curious if the set kind of works for a while though, isn't it? And yeah, right back to this one. This one was good. What I'm guessing is that with more voltage on it than this meter can provide, the electrons are kind of forcing their way through for a while, and then the thing starts heating up internally. And, well, it acts like kind of like a leaky capacitor in that regard, I suppose. So, out you go. Now, did I pay attention to what end went where when I clipped it out? No, of course not. I think the cathode was up at top. I'll have to compare that to the schematic. Alrighty, I got it in there. And I misspoke. The cathode goes towards the bottom, towards the chassis. That's a junction of two resistors. And the anode goes to the topmost terminal. Alright, let's put everything back together and give it a whirl. Okay, fingers crossed. Hopefully this will do the trick. And then we can start buttoning everything up. If the owner wants to do a full restuffing, I'll do that separately. That will be a bit involved. Don't have the converter box turned on. Oh, by the way, I got some bad news. Channel 6 in our area no longer broadcasts an analog signal. It's a FM radio station, and now they are broadcasting a digital video carrier. So it looks like you'll never be seeing me test a set by using Channel 6 again. That looked really bad when we first turned it on because I had the contrast cranked all the way up from our testing. So see, we have way too much width now. It's curious how the detector diode had such an impact on other aspects of it. Well, I guess when you don't have any sync pulses, the horizontal and vertical are kind of going to get kind of wonky too. Alright, things are looking really good. Make sure we're still sound. Sound isn't so great, so I think I'll need to do a little bit of tweaking on that. I think there's two coils for the 4.5 megahertz IF, and then there's a ratio detector coil. I think a little touch up on those should help. Now that buzzing, when you see these commercials with this really harsh text on there, that is often impossible to eliminate. But there shouldn't be any buzzing here.
Grant's advice was start with film. Film teaches you to slow down, to really think about each shot.
Now back to the cabinet. I've done about half a dozen passes of polishing up this corner, and it looks considerably better. Is that area that was sanded completely invisible? No, but it's considerably better. And I think unless you knew it was there and got it at the right angle, you wouldn't notice it. I'll do one or two more passes, and then I think I'll put a light coating of wax on it, and that should be it. I'm going back over my previous work now and tidying things up and replacing some of those resistors in the high voltage divider. Now, this may surprise you considering how much I've been talking about the originality of this set, but I'm actually going to recommend to the owner that we don't restuff the caps. I'll tell you why. It's one thing to clean off the wax and put a new part inside, but then we need to install it. In order to install it and make it look like it did originally, I need to clean off all the remains of the old leads from the lugs, from the tube socket pins, from the terminal strips. Not only is that a lot of work, but every time you do that, you stress those components out to unwrap the stiff, heavy old wiring, and then to put the new wiring in, and then solder it all back up. I've done it a few times. I know what it involves. It's kind of a drag, but I think it would actually do more harm than good to try to go over and put that much stress on hundreds of connections. But I did save everything, and I will give that all to the owner. Alright, let's wrap this puppy up. I've been making notes as I worked on this set of things I wanted to get back to tighten up once the set was working, and that's what I've been doing now. So I went through and I replaced the high voltage resistors, and I did replace the ASC caps with the WIMA, especially after I looked at the current state of the supply chain of components, specifically high voltage caps. They're really hard to come by. Even these, like Mauser is out of stock, I believe, with the 4700s, and they won't have any more until like 6 months from now. I think DigiKey might have some, and I think Mauser might have the 6800s. You can go a little bit higher in value, or actually, I think you can go considerably higher in value, but don't go lower. Like, I think you could use all 4700s in place of the 1000s, which might not be a bad idea, and I'll show you why. So these have short leads. They're meant for PCB mount. But notice the 4700s have much longer leads. They're actually almost long enough down here that you can use them with not much of an extension. Just something to keep in mind if you want to go with these. So why did I go with these? Because these are obtainable, at least to some extent, if you hunt around. The ASCs are virtually unobtainable. So that's what I went with. They work perfectly. I've used them in a bunch of sets now. One thing to be mindful of when you work on high voltage stuff is be sloppy but keep it clean. What I mean by that is make big, round, bulbous, sloppy solder joints. Don't be afraid to use too much solder. You don't want to have any sharp points anywhere. Corona is an issue with these sets. That's on this side of the caps. This side of the caps, lower voltage, not a big deal. This side, yes, and same with all the resistor joints. So I made sure to put big blobs of solder on everything. And keep it clean. You don't want to have any arcing. This set is especially, that's probably the cleanest I've ever seen. Normally there's a lot of dust and debris, cigarette residue, whatnot, that gets attracted to this set through holes in the chassis and whatnot while it's running, because high voltage builds up a static charge. It attracts junk. I mean, there is some in here. It's just not as bad as what I'm used to seeing. So it'll build up enough you can start getting corona discharge between various points on this. I've seen some sloppy solutions like to glop on liquid electrical tape all over this stuff. Don't do it, because it's a nightmare if you ever have to service it. If you really do need to insulate it, get something called Gliptol. Or red Corona dope or Corona dope, red varnish. They're all they're all liquid electrical insulator materials meant for doing this stuff. You can paint it on. The Corona dope is the most expensive, and it's good for many thousands of volts. There are a number of ways of replicating the ballast that came in this set. And the concepts apply to series strung radios as well, and other model TVs. So I think it deserves its own dedicated video installment. But suffice it to say, for this one, I used diodes. It turned out nice and small. It easily fits inside of the original housing, and it works great. So that is what I'm going to go with. I've been power cycling this set over the last 20 minutes or so to make sure that everything's working well, and it is so far. Now, I restored about 20 or so of this type Motorola over the last 15 years, and I've gotten to know their quirks pretty well. One of them is that you can get everything perfectly adjusted while you're watching it, with the height and the width and the sync. Turn it off, turn it back on a while later, and if you're lucky, you'll get the sync back, but sometimes you have to wait quite a while, or you have to touch the controls on the back, only to have it lose sync again in half an hour or so. That's what I'm talking about. It's usually the horizontal. Often, if you're patient, wait a minute or 2 or 3 or 4, it will lock. Now, if you're patient, let's reach back and give it a slight tweak. And there we go. Well, that's just the charm of these old sets. Alright, so it seems to be working quite well. No issues have cropped up. Next, look at the test pattern generator going. And that's what I'm talking about. There we go. Today we are using a Sencor VG91 for our test pattern generator, set to channel 4. We'll go through some various patterns and RF levels and make sure the set is working correctly. I'd say we're off to a pretty good start. This is without me touching anything. If I touch the fine tuning to the left, it gets lousy. It's a pretty good, clear, strong sound, and the video is pretty good. If I go towards the middle, we lose the sound, just like the converter box was working. Okay, so let's see, what can we tell? Let's go to a different pattern. Looks like we've got too much height. Let's get a circle on there. Yeah, we have a little bit too much height. It's a little egg-shaped. Adjust the controls a little bit so we can see that better. Now, of course, I can play around with this when it's in the set, and we've got the masks to guide us, but there, that's a little bit better. Now, there are no vertical or horizontal linearity adjustments you can make on these sets. But the only thing you can do is just make sure you've got some good tubes in there for the horizontal and vertical deflection. So let's turn the sound down so you don't have to hear that annoying tone. And let's try some other patterns. So circle, crosshatch. This one shows us the bandwidth, and wow, that is very respectable for bandwidth. When you can distinguish stripes basically all the way off the screen to the right, that's really good. And this is a budget set, keep in mind. Tweaking the fine tuning a little bit. Yeah, so that's why I don't want to mess with the alignment, certainly not the video alignment. Alright, it's very good, very good. Here's one last look underneath the chassis. And yeah, you may notice I didn't add any terminal strips. I didn't restuff those electrolytics. They're mounted around the chassis. Now, one reason I can do that is the caps that I used, I not only name brand, but they're higher ripple current versions, which means they have thicker leads. So these aren't going anywhere. These are all mounted very securely. Like the leads on these 3 amp diodes are really, really heavy duty. So by attaching or using existing lugs as tie points, everything is very secure, and anywhere I had to splice something, I of course put heat shrink tubing over it. So I'm not concerned about that. I think this thing is very secure and safe. So time to slide this back into the cabinet, and I got to dig up some new feet for it because the original ones are all rotted away. I'm putting the final touches on the cabinet, and boy, I am surprised. I was wrong. When I first saw this set, I was convinced there was a scratch up front that we'd have to try filling in. No, that was some surface crap. This thing is darn near flawless. That is one pretty hunk of bakelite. That sanded area is virtually invisible now. It's not every day you see a bakelite cabinet this large that is in this good a condition. Alright, things are looking and sounding pretty darn good. Just had to kind of tweak everything. Sound is really good.
Stay here and try and get back down!
Well, there's nothing we can do.
And a really sharp picture. This set came with a full set of Motorola branded tubes. One or two of them had yellow ink on them, which may indicate they were replaced by the dealer, and the font's a little different, so it's a little hard to say if they were all the original tubes, but certainly all Motorola branded tubes. Well, during the course of working on this set one by one, I eventually ended up swapping them all out for new old stock tubes of different brands. Well, I went back through and tested them all again with my Hickok Cardmatic this time, and ended up weeding out just these two, a 6SL7 vertical deflection and a 12SN7. There are three of these in this set. I don't recall which exact one this was used for, what circuit it was used in. So let's see how it plays, with just two replaced tubes in it now. That is very typical of these Motorola sets, how the horizontal sync just slowly eventually locks in.
No, I can't sleep.
Oh, that's looking really good.
I keep seeing that horrible face. I can't begin to tell you what it was like in that shop.
You need to watch these sets in a dim room. That's just a fact of life. These electrostatic CRTs just don't produce that bright of an image. If you crank up the brightness, the image just tends to get washed out. Then you turn up the contrast, and it just doesn't look so good. So yeah, you just have to be in a dim room so we can focus a little bit. Well, that, I think, is as good as it's going to get. And that may be the best looking Motorola electrostatic TV image I've ever seen.
I just don't understand it.
Look at that pretty bakelite that's polished up so nicely. The sanded off area, if you feel it, it's a slight texture difference, and if you get the light just right, you can kind of see the sheen is a tad different. But boy, I mean, unless somebody told you about it, I don't think you would ever notice. Project was a bit more involved than I thought it would be, but I'm happy to have gotten to work on such a pristine set, and the final results, I think, speak for themselves. That works very, very well. I hope you enjoyed this look at restoring a Motorola 8-inch set from late 49, early 1950.
All the rest of us,